Hello everyone and welcome to today's lesson. We're going to start a brand new chapter on chapter 10, and chapter 10 is all about radicals. Okay, and we've talked about radicals before. We've talked about that there's square roots and cube roots and fourth roots and so on. But this chapter is only really about square roots. All right, so let's get started first with a little vocabulary. A radical expression is any expression that contains some kind of radical or some kind of root, whether it's square root or cube root. And we can simplify radicals. Okay, so this is what our goal is today, is to be able to simplify radicals. We're going to do it by removing perfect squares from the radicand, which is the number underneath the radical sign. And before we get started, I'm going to start off with perfect squares. Now, the smallest perfect square is 1 times 1, which is 1, but we're not going to be using that one. That's like one of the only ones we're not going to be using for this lesson. We're only going to be using positives 2, so keep that in mind. All right, so 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 is 49, 8, 64, 9, 81, 10, 100, 11, 121, 12 is 144, 13 is 169, 14 is 196, and 15 is 225. Now it can go on forever, but these are going to be the ones that we mainly will be using, and honestly, most of them will be under 100. Okay, so the best way I can compare this lesson is that it's kind of like the fraction 10 over 20. So just like fractions, where we want to simplify them, we want to simplify our radicals or our square roots. Now, just like fractions as well, maybe we could divide them both by 2 and get 5/10. We might be able to simplify again if we didn't pick the biggest number first to get our final answer of 1/2. So we're going to keep going until we can't go any farther. So just like fractions, radicals might come into the same kind of concept. They might have to keep going if we didn't get the biggest one first. Okay, so let's look what this looks like. So think about all those perfect squares that we wrote down and then see which one 54 is divisible by. So I know in class a lot of students were taking 54 divided by 4, 54 divided by 9 until they found one, and 9 goes into 54. And actually 9 times 6 is 54. Okay, so that's our first step, is to find the two numbers that you can multiply to get 54, and one of them has to be a perfect square. Because our final answer is, we take the square root of the 9, which is 3, that goes outside when we answer it. And when we don't know the answer, so square root of 6, it stays inside. And that's our answer. I know I'm done because I can only break up 6 into 3 and 2, and neither of those are perfect squares. So I'm done. All right, so let's try another one. We've got the square root of 20. The perfect square that we can divide 20 by is 4, and 4 times 5 is 20. And again, I'm going to square root the one I know the answer to. That goes outside. The one I don't know the answer to stays inside. So our answer on that one would be 2 square root of 5. For 120, I know 4 times 30 is 120. And I know the square root of 4 is 2. I don't know the square root of 30, so I keep it inside. Now 30 can break up into a few things. 3 times 10, 5 times 6, but again, none of those are perfect squares, even 2 times 15, but still no perfect squares, so I know I'm done. All right, we can do 147, see what that one's divisible by. That one's a little bit tougher. I believe it's 49. Let me use my calculator here to double check that one. Yep. So 49 times 3 is 147. Go ahead, square root 49. That's 7. Don't know the square root of 3. I'm done. Next one, we have 24. 24 is 8 times 3, 12 times 2, and 4 times 6. 4 and 6 are the only ones that one of them is a perfect square. Square root of 4 is 2, and keep your square root of 6. Final answer. All right, so here's what I was talking about. Maybe you didn't get the biggest one. So if we were doing square root of 80, maybe you knew that 4 times 20 was a perfect square. That's perfectly acceptable. Square root of 4 is 2, and we don't know the square root of 20. However, square root of 20 breaks up into 4 times 5, and 4 is a perfect square. It is 2. So since we knew the answer, it has to come outside with the other 2. And when there's 2 numbers outside, we multiply those together. So this would be 4, and no longer the square root of 20, it'd be the square root of 5, since we broke up 20 into 4 times 5. So that's kind of the slow way of doing it. If you found the biggest one right away, just like fractions, if you found the biggest one right away, it gets you there more directly. This would have been 16 times 5. And then the square root of 16 is 4, and we don't know the square root of 5. So that way is a lot quicker. However, if you don't get it right the first time, you can keep going and get it right the second time. All right, go ahead and try these 2 on your own. Go ahead, pause now, and when you're ready, play, and we'll go through the answers. All right, this is what you should have gotten. 98 is 49 times 2. That would give us an answer of 7 square root of 2. 108. 108 is divisible by 4, but that's not the biggest one. So let's just do 4 to start with, because I know 4 times 27. So the square root of 4 is 2. The reason why I said I know it's not the biggest one is because 27 can be split into 9 times 3. And the square root of 9 is 3, so that would come out front with the 2. And that means we multiply them, so it'd be 6. And then we'd have the square root of 3 left over. So the most direct route would have been to break up 108 into 36 times 3. That would have given us the square root of 36 is 6, and would have left us with the square root of 3. So either method, you would have got the same answer. All right, we're going to move on to ones that have variables now. Okay, so if I'm trying to find the square root of x squared, I'm trying to figure out what number times what number gives me x squared. And the answer here is x. X times x gives us x squared. Now, if that's confusing, what I told my students is to kind of expand it in your head. How many pairs of x's do you have? I have 1 pair. If I know the answer, or that's all I have to do, is I have to say how many pairs. So there's 1 pair, so x to the first. Okay, so let's see w to the 8th in action here. I'd have 8 w's, 1, 2, 3, 4, 5, 6, 7, 8. How many pairs do I have? Well, 1, 2, 3, 4. Our answer here would be w to the 4th. Okay, so that's if it's an even exponent. So a lot of people in class realize, oh, I could just cut the exponent in half, and that works. But it doesn't work if it's an odd exponent. So let's look at odd exponent. So I'm going to expand x to the 3rd, so x times x times x. Again, I say how many pairs are there? So 1. The pairs go out front. So 1 pair, so 1x goes out front. Now the leftovers stay inside the radical. I will always have 1 left over. I can't ever have 2 left over because then it'd be a pair. So the most I could have is 1 left over. So let's see what this looks like with w to the 7th. So 1, 2, 3, 4, 5, 6, 7. All right, how many pairs of w's? 1, 2, 3 pairs. So w to the 3rd goes out front with 1 w left over. So we're going to keep that inside. So how many pairs go out front? How many left over remains inside the radical? All right, so let's see what this looks like. We're going to mix it in with what we've already learned with the numbers. So break it apart, do it section by section. So first off, is square root of 25 a perfect square? Yes, it is. I already know the answer to that. Square root of 25 is 5. That stays out front. All right, a to the fourth. How many pairs of a's do I have? 1, 2, nothing's left over. Pairs go outside, leftover stays inside. In this problem, nothing was inside. Square root of 45. That is not a perfect square. We don't know the answer to that, so we have to split it into 9 times 5. Square root of 9 is 3. That goes outside. Square root of 5 stays inside. I don't know the answer to that. Now we're going to go to the y's. How many pairs of y's? We have 5 pairs. Pairs go outside. Leftovers stay inside. I didn't have any leftovers, so this would be my answer. All right, number 3, square root of 49. That's a perfect one. I know that answer. That's 7. W to the 7th. How many pairs are there? So 1, 2, 3, 4, 5, 6, 7. How many pairs? There's 1, 2, 3 pairs. So W to the 3rd out front. 1 left over. So 1 stays inside, and that would be our answer. All right, why don't you guys go ahead and pause now and see if you could do this on your own. All right, here's your answers. Square root of 18, not a perfect square, break it up. 9 times 2. Square root of 9 is 3. That goes outside. 2 stays inside. All right, do letter by letter here. A to the 4th. How many pairs? We would have 2 pairs. Pairs goes outside. On B, we'd have 5 B's. That would give us 2 pairs with 1 left over. That should be our answer for number 4. Number 5, square root of 36 is a perfect one. It goes out front. 6. X to the 8th. How many pairs? We have 4 pairs. We're going to do Y's next. 5 Y's. There would be 2 pairs with 1 left over. And last, the Z's. There would be 1 pair with 1 left over. That's what you should have gotten for your final answer. All right, last I'm going to show you just one of these problems. In class, we only had to do one, and that was plenty. All right, so they chose a lot of them, number 6. So if there's a number out front, only thing is we have to multiply it if anything joins it. Okay, so square root of 4, that's a perfect one. It goes out front. Square root of 4 is 2. And the only thing I have to do when I have 2 numbers out front is multiply them. So this would be 10. Now I'm going to do a to the 5th. That would be 2 pairs of A's and 1 left over, and that would be our final answer. All right, hopefully this is helpful. If you have any questions, don't hesitate to send me a message. See you guys.